Okay, Qing Zhou, please start.
Hi. So this paper is what happens after you leak your password, understanding credential sharings on phishing sites. So basically, what this paper does is that it tries to understand the data flow all the way from the user to the end to the phisher, and then to how does the phisher exploit it. So in this summary, I'll go through the key points, which is firstly I'll introduce phishing, then I'll do the analysis of the client-side traffic flow, analysis of the server-side traffic flow, and the analysis of post-phishing exploitation. So I'll answer this series of questions about the phishing behavior. Okay, so what is phishing? Phishing is basically a site that seeks to steal your credentials. As you can see here, this is a phishing site for PayPal, and this is a phishing site for Facebook. So let's first analyze the client-side traffic flow. So what exactly is client-side traffic flow? Okay, so this is the overall phishing attack process. Firstly, the user will enter credentials into the client phishing site, which will assign the credentials to the phishing server, and then the phishing server will either send an email or somehow to the collector, and then the collector will carry out malicious activities on the user. So for client-side traffic control, what we mean is the first part. How does the phishing page send credentials to the phishing server? That is what is meant by 2.1. So how is client-side traffic flow analyzed? Basically, the researchers use Selenium to crawl phishing sites from OpenFish and submit the form data. The tool then detects a login form and automatically fills in the form and submit the data. Sorry, I repeated myself here. My bad. So basically what they do is they just log the traffic by automatically submitting the data. So one question that the researchers seek to ask was, does the accuracy of the credentials matter when submitting data to a phishing site? So based on the mini experiment they conducted on 60 phishing sites, the network data collected showed that there is no difference. However, just now, for the HSBC site that I showed you guys, there actually is a difference when you submit an incorrect username or a correct username. But yeah, this is just their experiment results based on the 60 phishing sites that they conducted on. So how are credentials transmitted from client to server? So URL encoding is used most of the time. This basically means that if you analyze the traffic, the username and password can be seen from the browser. So basically it's stored in plain text. It's stored in plain text and it's not encoded. So who are the phishing credentials submitted to? Of course, they are submitted to the phishing server, and in 5% of the cases, they are shared with the credentials are shared with third-party collectors. So basically, third-party collectors are defined as traffic flow to other websites that are not the phishing server.
So here are the questions. How does the researchers know, or what information does the researcher observe to know 5% of the phishing site is actually flow to a third-party collector? So anyway, what the researchers can observe is just about the client, right? Just about the client.
Yeah. So here we are talking about this area, 2.1 and 2.2.
Okay, 2.2. So okay.
The user client will send credentials to the phishing server, and also at the same time, the user client will share credentials with a third-party collector.
And how does technically how does the researchers do this?
So if you let me just show you a quick example. If you go to say gmail.com, you can actually this is how you do it manually, but you can inspect the network traffic flow from the website. Yeah.
So it seems that it has interaction with multiple parties, right?
Yeah.
Okay, so just based on IP address. So that means, so suppose I click the send button and submit my credentials to these servers. So from the browser level, or from just what I showed just now, we find there's the client or the browsers are building or establishing connection with multiple IP addresses. And
so for 5%, for 5% of the site, there is sharing with third-party collectors from the client.
Yeah. So here, may I say that 100% all of them are sending credentials to their servers, but
Yes.
5% of them say additionally send the client sharing the information to the third-party collectors, and
Correct.
they know this because they observe there's additional IP addresses interacting with the websites.
Correct.
Okay.
Okay, let me clear this. Clear all drawings. Okay, let's continue. So then they analyze who are these third-party collectors. So basically what they did, they just used a scanner to analyze what kind of third-party collectors at them. And from here, you can see that most of the third-party collectors URL, most of them are actually phishing sites also. There are other phishing sites. So what?
So they classify the phishing site, malicious site, and the malware site. So this information come from the scanner, all come from the scanner. And this scanner is supposed to be VirusTotal.
I don't think they use VirusTotal. They use something else. I can't recall what is it. Oh yeah, correct. VirusTotal. I'm sorry. Yes, VirusTotal. Yes. So they allow VirusTotal to classify it. So this is what the third-party collector URLs are, which is actually quite similar to the phishing sites with third-party collectors. It's not that different.
Distribution, intent to distribution.
So this actually gives an idea that often the third-party collector URLs are maybe another phishing site there.
So the classification is overlapping, right? So that means one site can be both phishing site and a malicious site.
Correct, yes.
Okay.
So I think these two are actually the same thing. But I think this is a malicious site is a broader category of the phishing site.
Yeah, definitely phishing is malicious.
Okay, yeah, let's go on. So what's actually interesting is that some legitimate domains were observed to host third-party collectors. For example, Dropbox.com and Google.com serve as third-party collectors, and there was an instance of a Dropbox link being used to collect the data. Some phishing sites were sending credentials to the legitimate websites that they were trying to impersonate. In this case, they gave the example of a phishing site for Delta.com that basically try to key in the data in Delta.com to make sure that the credentials are legitimate.
Now we analyze. I have a question here. So the first question is that it means that hosts on some website like Dropbox and Google are hosting some third-party collectors. So maybe I don't know this. Yes, Dropbox allows for intuitively, I think, for example, Amazon or the AWS service can host some service. Yeah. So it will be more straight. It's more understandable or make more sense that those websites are the phishing are sending credentials for their service hosted by Amazon. But the Dropbox and Google do the same things. It allows the user to deploy. Definitely, I cannot believe that the Dropbox and Google are compromised.
Yeah, right? Definitely not.
So the only explanation that those third-party collectors are deployed on the Dropbox and Google service. And apart from Dropbox and Google, what the other 12 legitimate domains?
They did not give all 12, but these are the examples that they gave. So let me just share with you. They gave some insight into what was Google.com used for. They said that Google.com was used for the advertisement tracking service. So basically, somehow the phishers were using Google.com advertisement tracking service to track how many users they were phishing. That was the example they gave. That was the analysis that they gave. And Dropbox.com, they just said that Dropbox.com was used to collect the data. I think it could be possible that Dropbox would provide an API to update your files, like a spreadsheet or something, and then they just use the API in order to update the spreadsheet.
So the idea is that attackers actually utilizing the well-known facilities like Google and Dropbox as a part of their API to conduct the whole workflow of the attack. For
Yeah, but
example, they need to track the information, they need to host the data, so they use Dropbox and Google's as the. So basically, it's not like a third-party collectors; it's just the facilities, right?
yeah, but just remember that that this is actually a very small portion of the total phishing collectors they got. They got 1,000 plus, and only 14 of them was legitimate. So that's like about 1% of the total third-party URLs that were used.
So here, what if there's some service which is neither legitimate domains nor the malicious website? So will you please go back to the previous slide? The previous slide.
Yeah.
So here, they find okay, they find over 1,000 third-party collectors, and the majority of them has been classified by the various totals, and there is just a small portion, which is not known, right? So this is kind of unknown site.
Yeah. So they actually did give the top, I believe it was the top 5 domains of third-party collectors. Wait, let me just double check it. No, actually they did not break it down for this one. I'm sorry. They did not break down the third-party collectors. They just gave some examples of it.
Okay.
Wait, sorry, they did. Let me quickly show it to you. So these are, sorry, I did not include this, but these are the top 10 domains of third-party collectors. Over here. Hello?
Yeah, I'm looking at it.
Yeah, so some of these are like, this is a web hosting app. So this could be also another phishing site. So there's an overlap of it. You know what I mean? Yeah. Hello?
Yeah, I'm reading. I'm hearing you. Okay.
Yeah, so this is what. Okay, let's move on. So now we'll look at the server-side traffic flow. So basically what we're trying to analyze here is this part. How does the phishing server send the data to the first part, the collector, and whether do they share the data with any other third parties? So how does a phishing server send credentials? So 91% of phishing kits use emails to send credentials, and 9%, the other 9% did not use email, but there was no other HTTP traffic observed from the phishing server. So this means that it's likely that the attackers will log into the phishing server to retrieve stolen credentials manually.
But how do they get this information? So
wait, sorry, I skipped a slide. Sorry, I skipped a slide. I'm sorry. No wonder I was like, what's the flow? So how they did it was they collected phishing kits and examined their code. So they did this by accessing the phishing sites and check for the visible directory domains and searching the directory for tar, JZ or zip files. And they managed to obtain 2,000 phishing kits from 179,000 phishing URLs. And then they deployed these phishing kits to a test server and analyzed the traffic flow.
So in this case, you can see giving this number. So we were talking about the visibility. So the visible directory is right. So getting their data, there are at least over 2,000 phishing URLs with visible directory, right? Otherwise, they cannot achieve these over 2,000 phishing kits.
Yes.
So visibility may be still interesting domains, but maybe we haven't been able to explore it at this stage.
But I think a problem potentially could be that only the phishing directory is visible and not the whole website is visible.
It is arguable. We need to evaluate it. And
yeah,
the researchers share those over 2,000 phishing kits.
Sorry?
I'm asking the researchers publish these 2,000 phishing kits.
They did not.
They did not, right?
Yeah, but I think I came across one before that there's a GitHub where somehow they managed to automatically they have all the archives of all the phishing kits. I can send it to you if you're interested in.
Yeah,
In
you
the
can
phishing
send
case.
you can send the link to me about the phishing case. If possible, we can also send an email to the authors to achieve those phishing kits. So that is somehow interesting. But I have to think about how to use these phishing kits. Okay, so when they deploying the phishing kits on the test servers, but this test server is still not a phishing server, right? So it's just simulating the phishing server.
Sorry, yeah, it's just to simulate and then analyze the traffic from that test server to the external world. That's what they're trying to do here.
Yeah, but what we're talking about is that what after the server has already gained the credentials?
Sorry? Oh, like this part, is it? What happens?
Yeah,
like
we're talking about this part. So here, the phishing, here is the, you can see this website, the phishing webpage or phishing website is the place where the phishing kit is deployed, right? And
Yeah.
after it got information, it's sent to a server here. And this is not where the phishing kit is deployed. That is a private server or some, we only know this IP address.
This is where the phishing kit is deployed. No, the phishing server is where the phishing kit is deployed.
Phishing server is phishing server. How do we define the phishing server? Is the phishing server the server hosting the phishing page?
Yeah.
Okay, so this is a phishing server, and then it's going to observe how the phishing key works. Oh, I see. Okay.
So yeah, we are observing this part over here.
By
how does the phishing?
By far, I'm the only one who raised the question to you. And have you ever sent questions to the audience?
Oh, actually, every single one of them were all questions, but yeah.
Okay.
Yeah. Okay. So yeah, I just sorry, I just phrased the whole thing like a question.
Okay.
Okay. So how does a phishing site server send credentials to other people? So 91% of the phishing kits use email to send credentials, and 9% of the phishing kits did not use email. But as there was no other HTTP traffic observed from the phishing server, they suspected that the attackers would actually have to manually log into the phishing server to retrieve the stolen credentials.
No, here, I have a question for the last sentence. No HTTP traffic was observed. So how did the authors observe the traffic from the phishing server?
So here, the
problem is that they have deployed the phishing kits on their own server. So they are observing whether their own server have any traffic, building any HTTP traffic within the other servers. Okay, I see.
Okay, yeah. So okay, so who does the phishing kit send credentials to? So here we have the top 5 first-party collector emails, and here we have the top 5 third-party collectors. Okay, so third-party collectors in this case, right? They define it as emails that do not appear in the source code in plain text, but are detected in traffic analysis. So what this means is that the phishing kit actually has a backdoor that allows the producer of the phishing kit to obtain stolen information also. So basically, how this works is that these phishing kits are sold on the dark market, on the dark web for a price.
So here, what does the plain text mean?
Okay, so here they define third-party collectors in this case as emails that do not appear in the source code. So like if you Control F for email for an email account, you will not find these top 5 third-party collectors.
So here the point is that they but you mentioned that there's no HTTP and HTTPS traffic from the
there's an email traffic.
Okay, there's email. So there's other kind of traffic, but not HTTP and HTTPS traffic.
Yes.
So but it means that it still actually communicated with the others, but usually by email, right? So if but the email, only traffic that but given that means that the email traffic is not encrypted.
I think so. Yes, it appears that way.
So otherwise they cannot have the. Oh, not necessary. So even if email content is encrypted, but it still somehow need to know the
email
destination.
address.
Yeah, the destination of the email. So in this case, they can analyze those emails, and those emails are almost all of them are using Gmail to reject it.
Yeah. So so third-party kits in this case are third-party collectors are defined as emails that do not appear in the source code in plain text but are detected in traffic analysis. So these are likely to be a backdoor implemented by the seller of the phishing kit so that they can have access to the stolen credentials too. So yeah, there is this guy that has 10 phishing kits and 6 domains, and this shows that actually a lot of phishing are done by the same party. Like there's the same few emails that are doing the phishing.
So it's more like a fisher, right? So here is more, and I still have a question for table 11. So top 5 first-party collectors. So what do you mean by first-party collectors?
So first-party collectors are emails that are entered into the source code. So if you think of it,
okay. So okay, I see. No problem. But how? Okay, so given the phishing kit, okay, giving that is the case. So given the phishing kit, it will send the information of credentials to both of a first party and a third party collectors. So is there a third party collector?
Sorry?
You can see there the first party, third party, but we're the second party.
Sorry, I can't hear you. Sorry. What did you say?
I'm asking it. Can you hear me now?
Yeah, I can.
I'm asking that there's the first party, third party. So where is the second party?
I have no idea, but they just define it this way.
Okay.
So I have no idea. There's no such thing as a second party, I think. They just defined it in this particular way.
So you can see there are the distributions, and but may I ask how many third parties? How many third party do we have?
So it's in the next. Wait, give me a sec. Sorry, I did. How many? There was a number, but I forgot about it. Give me a sec.
I know that the total number of phishing kits is 200, over 2,000, right?
Yeah. So they managed to find 4.2% of those phishing kits had a backdoor email. So 4.2, which is like 80 plus, had a third party collector.
Oh, so it's close to have 100, right?
Yeah.
100 phishing kits, and
with a
for third parties. So more like the top 5 first party dominates the whole number of phishing kits.
Yeah, it appears so. So it appears that there are some like shady sellers that sell the same phishing kit that have backdoors.
Okay.
Yeah. Okay. So this just compares the server collector versus the client collectors. So this not. So basically, most sites actually have only one server collector without any client collectors. So in client collectors here, let me go back again. This refers to client site sharing. Here. So you can see here that most of them. Rely on server collectors only. So now let's analyze what happens post-phishing exploitation. So how do we analyze post-phishing exploitation? So here we are doing number 4, malicious activities. So how do the first-party collector and third-party collectors use these stolen credentials to affect the user, to perform malicious activities on the user? So how do we analyze post-phishing exploitation? Basically, we feed phishing sites.
May I look at the picture in previous slide? So yeah, there's the definition of third party and the first party. And the first party is more like a fisher themselves, right?
And
Yeah,
third
correct. So,
party is more like, yeah, I see.
so third party basically are those, in this case, they define it as people that they are not the fishers, but still get the information.
Okay, I got it.
So they fed real phishing sites with honeypot. So basically, a honeypot is a real account set up for the specific purpose of feeding it into phishing sites. So first question is, what is the time interval between phishing and exploitation? So they found out that exploitation occurs relatively quickly with the fastest between around an hour. With the fastest being around an hour. So, but this shows that actually is not automatically done, but rather it appears that this exploitation is manually done.
How does the authors know the exploitation happens?
Sorry, how do the authors know whether how the exploitation happens?
Yeah.
So when you create a Gmail account, you can actually check where your email is logged in from in the.
But then it's only for Gmail.
Yeah, correct. So basically, what they did was they fed phishing sites with a real Gmail account. They did not feed the site with so if the site was a PayPal, they did not feed it with a real PayPal account, but they only fed it, the real account is only the email account.
Okay, the point is that when you're getting email accounts, the attacker assumes that the user will use all the passwords the user will use the same password for all the servers, for all the accounts.
Yes.
Right. So even if it is PayPal, and when he got a Gmail and get a password, he will try this Gmail and this password for his Gmail account, even if he got it from the PayPal. Right.
Yes.
Okay.
That was the analysis after that. So the case study of exploitation done is basically that 35 minutes after leak, the first account was the fastest attack, where within 35 minutes of leakage, the attacker logged in and tried to register an AWS account using the honeypot account, but they were failed because of the payment failed to go through. And then in the following 5 days, the attacker logged in an additional 8 times without performing any observable activities. Then for account 2, 3, 4.
So here that using
the attacker logged into the email account.
Yeah, but why are they going to register an AWS account?
Maybe because they want they are trying to set up. Maybe they were trying to set up an AWS account so they can quick set up more phishing sites or something. I don't know.
More phishing. That's one explanation. Okay, please hold on.
Yeah, maybe they're trying to set up more phishing sites or something like that.
So how many accounts?
Sure.
How many honeypot accounts is there? 4 accounts or
they had 60. They had 64 honeypot accounts, but they shared But I just summarized it into this main behavior because the rest were similar behaviors.
But how does the researcher know these accounts have been used? Oh, so because when you register an AWS account, it will receive emails.
Yeah, correct. You will receive an email that they registered an AWS account for you. Okay, so the analysis shows that the attackers generally try to access the email account even if the initial vector of attack wasn't email. For example, the initial attack was on PayPal, but they still try to access the email account. And the irregular patterns of time access show that the exploitation was probably done manually. So basically, there's no fixed time for the attacker to log in, but it's random, basically. Yeah. Okay. Yeah, that's the end.
Okay. Thanks, Qing Zhou. I think this report is clear. So we will go back to the overview and the graph here. Also, sorry, please share your slides again.
Yeah, okay, give me a sec. Sorry. Where is this? This one, right?
Yeah, these ones. So let's link back to your research. Your research is going to observe the interaction between the user and so you're trying to look into the interaction on these two parts, right?
Yeah.
This is what we said. But so giving these papers might be we still be
we're still able to look into the interactions on 2.1 and 2.2. But definitely we do not have access here, right? We don't have access to
one
phishing.
one thing that I thought was interesting was this one. Let me show you. It was this slide. Wait, this one. The fact that most phases actually use URL encoding, which means that it's not that secure. URL encoding is not as secure as like hashing it or something like that. So this could probably be a feature. So whether how is the username and password transmitted from the client to the server?
But when you are clicking submit, so this information can be observed from the client side.
Yeah, correct. So basically, this is how this is this part. Wait,
So basically, you just observe the network from the browsers and to see how these informations, or you're going to observe the way who send the credentials to the phishing server.
Yeah.
Yeah, so you can see what if you're using your encodings, it's somehow more like phishing. So that's what I plan.
Yeah, I was thinking of that. Like that could be an additional feature too, other than just how the response, but also how the data is treated.
So let me think about it. So client. So here is the browser, right? This is the browser.
Yeah.
This is the browser. So the browser smells the interactions. Yeah. So I think one of the ways that you're going to encoding all the net sorry, we encoding all the network traffic. So and may I have a look at the table, your previous table?
Yeah, sure. Wait, I need to. This one, yeah.
And how does the plain text is presented, and how do they classify the credential transmission is through plain text?
So plain text basically means that the URL appears, the email and the password appears in the URL itself.
Okay, and the URL encoding, and how about what about URL encoding? So they using
it appears in, like, when you submit like a post form, so it's just exactly like a post form without any hashing or anything like that.
But even for the URL encodings, we can still observe the plain text of information or the plain text of the credentials through the network level.
Yeah, correct. We can. I think it will appear in like in the request headers. Like if you went to Chrome and use the inspector and the network, like if you.
I think this is a very interesting finding, that because for Google's, PayPal, etc., they usually use they will usually use encryptions to encrypt the username and password and send it back to the servers. But in this case, even if they are using, I suppose that this special website is HTTP using HTTPS, and their communication is encrypted. But when you send information, you're not going through the encryption channel.
Yeah. So like normally yeah.
So maybe you can try or evaluate with more samples yourself. You can see there's a plain text, there's URL encodings. Maybe in your morning meetings, you can select a few samples and show the network flow between the browsers and the phishing servers. We're going to see how the network looks like. And also we compare the network flow or network route between browsers with a legitimate domain or legitimate website like PayPal, Gmail, etc., and observe the difference. Then maybe that's the way we can distinguish from the phishing and non-phishing from network flow. But of course, remember that there's a denial website which can jump to
PayPal. Do you remember there's been a website looks very suspicious. We think it's a possible phishing, but it can jump to the legitimate PayPal website. In this case, we may still take those into consideration.
Yeah. Wait, let me try to find it so I can show everyone what we're talking about.
And also remember that you can, because in your research, you are going to remove those plausible phishing websites. Plausible means that it looks like a phishing website, but actually it's not. So in this case, then how the interaction can bring us more insight. And from a network flow perspective, definitely to bring us a clue. And of course, what if from the other perspectives, whether the network flow itself can address all the problems or what we can extend, what features we extend to make the whole study more comprehensive. Okay, that's my comments. And I think you make a very clear explanation. Let's talk about more technical details on the day after tomorrow. That is Monday.
Yeah. So actually, this is the site that just it looks exactly like a PayPal site, but it redirects you to the thing. And what is different from normal phishing site is that I don't think normal phishing sites, they don't have this kind of animation. Like they won't bother to do all this. Like I've never seen a PayPal site.
If they copy paste, if they download the website.
Yeah, if it was like a phishing site, like they won't have all this animation. It's just too much trouble to bother with all these like things.
Okay.
Yeah. Okay. Yeah, that's all for me. Thank you very much.
Okay. Thank you, Qing Zhou. Next one. How about let's have a 5 minutes break. Then let's invite Yihao to present another deep learning approach. So it is actually a combination between deep learning approach and a software engineering. So in Yihao's presentation, he will introduce a technique. How do we translate a program language into a natural language comment? If this technique is very successful, we do not bother to leave comments. The machine translation can automatically understand what the program is doing and generate comments for human beings. That will be a very important, or that will be very convenient features for in terms of from the software engineering, especially for software engineers. So let's have maybe 5 minutes break. Let's meet at 3:17. Then Yihao, you can share your slides now, and on 3:17, we're going to start the presentation.
Okay.
Hello. Hello, Yihao.
Yes.
Okay. Please start.
Okay. So hello everyone. Today the paper I'm going to present is called Retrieve and Refine. Exemplar-based neural comment generation. This paper is first published on ASE 2019 with a short version with 2 pages, and then I think it's at last month it's published again with more comprehensive experimental results and details.
It is short paper.
No, it's a long paper.
Okay, it's a long paper. Okay, so
Yeah.
it's originally started with a short paper version.
Yeah.
Then publishing the full papers in ASC 20.
Yeah, last month. Here are the authors of the papers. 4 of them are from the other researchers or professors from the key lab of high confidence software technology at Peking University in China. And one is the research fellow at Monash University.
新夏 supposed to be a lecture in Monash University.
Oh,
I
okay.
think maybe it is maybe the information is obsolete. Yeah.
Yeah. It's quite hard to search for the information.
But some of the professors, I think the last 3 are very famous researchers in software engineering area.
Okay. Okay. Okay, so let me introduce some background knowledge before we get into the papers. This paper is addressing the problem of code command generation, and the task is aiming to automatically generate natural language descriptions for source code. And in general, we can classify the current methods into three categories. The first one is a traditional method called template-based method. It is to define different templates for different types of programs to generate readable text descriptions. And the other one is called information retrieval method. It is to use IR techniques to select terms from source code to generate term-based commands, or leverage code column detection techniques to detect similar code snippets. And the third one, which is the most popular techniques, is called neural network method. So it is to adopt the encoder-decoder framework of neural machine translation. This means that it is viewing the task as a translation task is to translate the code to natural language commands. And here in the neural network method, the source code is the input and the commands is the output.
So this work just belong to the third category.
Actually, this paper is involving all of the method.
Okay,
all of the three methods.
so it itself is a hybrid approach.
Yes.
Okay.
And this is some common used general framework for the code command generation. The first one is comparing the existing code and the target code. And once we found that there is an existing code which is quite similar to the target code, then we can reuse the existing commands and by using some optimization rules to generate the target commands. And the other framework is extract the structural and semantic information from the source code by using the neural network model, and by using the decoder in the model, we can generate the commands.
Okay.
And for the challenges of each of the methods, we can see that for the template, it is very obvious that if we want to define a template, it is quite time consuming. And also if we want to generate commands for different projects, then we may need to define different templates. So this is the disadvantages for template-based method. And for information retrieval method, the code snippets may contain some information that is inconsistent with the content in commands if we want to reuse the existing commands. And for the neural network method, usually it will only generate some high frequency words in the commands and ignore some low frequency but key information words. And
So what does that mean? Means lose control.
Lose control means it will generate some like repeating words.
Repeating.
Yeah.
Repeating words. So how?
Maybe
maybe can you have the examples later?
Not specifically for this case, but from my understanding, the repeating is just the model thinks some keywords are very important. Then in the generated commands, it will repeat the keywords for several times.
Okay.
Yeah. So here is a question for the audience. can you list some advantages for any of the three methods I just described?
Okay. Oh, so there are the questions for audience, right?
Yeah.
The question is, what is the advantages between these three methods?
Yeah.
Okay. So given that, maybe you can pick up ones. Is 学制 here?
Yeah.
So this work is somehow, I think we all see this was somehow related to the research in the Fudan lab. So I choose you, maybe you can have a try to answer this. So do you need Yihao to repeat the question?
Repeat question.
So I mean, here I have listed the disadvantages for these three methods, right? So can you?
And those methods are all would like to translate a source code, a piece of source code to the natural language descriptions for the code. So now so giving there a description of the template-based methods, information retrieval-based methods, and the neural network model methods. What do you think the advantage and the disadvantage between these three methods? Among these three methods. Maybe I think Yihao, you can prepare some pictures or examples here. It might easier for the other student to grasp, because I feel that only you and I has a background. And
Okay.
even if I point out, maybe I can describe the things a little bit. So the template-based approach, as far I can describe it here, because even 学制, maybe 学制 does not understand that, we will point some other students. So let me repeat or giving some example here. So for the template-based approach, is more like suppose the source code looks like this, and there's a for and if, and this one there's a match, and then somehow return, right? So suppose so in this case we define a lot of templates based on source code. As long as the source code match the template, we can generate comments based on template. For example, giving these source code structures, we can say it somehow will calculate the minimum of the list, or calculate the maximum of the list. So all of them are based on the template, and also they're going to generate extract some keyword in the source code, so that the template will be, there was a slot in the template. Overall, given the structures, the template was saying that this piece of code is going to calculate the minimum or maximum of a certain list. And what is this about? So it will extract a keyword to fill in that slot. So this is a template-based approach. And as for information retrieval approach, on one of the examples I think we can raise here is about the code clone. And 学制 you are somehow know about code clone, right? So the idea is that suppose the piece of code is already has some comments here, and if there's another piece of code which is very similar to this code, we can somehow borrow the piece of code, the comment here, to reuse the source code, to reuse the source code of previous code, to reuse the comments of the previous code as the comments of this new code. So this is more like information retrieval methods. Moreover, information retrieval methods will also treat the source code as the languages. It's going to automatically summarize those languages, those source code, the keyword like source code to extract some summarizations. And for the neural network models, it's more like a model translation model. So just like a translation from English to Chinese or backwards. So in this method, it somehow will will encode the source code, embed the source code, and feed them into neural network models. and the network is going to translate it, and auto code translate it into embedding the whole sequence. It regarded the piece of source code as a sequence of tokens, and it's going to translate it into the English. So that's more like a two piece of code. So more like English to Chinese, but now it's program languages to English. So you can think about this. I think I have already introduced these 2-3 parts of work. So now, Xuezhi, what do you think on the advantage and disadvantages between these 3 methods?
Uh, uh, I have a not clear point, a clear idea.
Okay, so how about Xiangling?
I didn't follow your point.
So somehow I suggested, so this work may not that relevant. Maybe later I will show that this work, because this is more about the machine learning and neural network model. So, okay. So in this case, maybe if there's no, so sorry, Yihao, you also prepare the next 2 questions later, right?
Yeah.
Okay, maybe you can give the answer here. And I hope all the students can maybe pay a little bit attention to answer the next 2 questions.
Okay. So for the
Sorry for the interruption. Is there any students who can answer this question?
Can I have a try?
Okay.
So I think for template-based method is something like a rule-based method. So it's a very straightforward way. Once you have the template database, then you comparing 2 pieces of code is actually a trivial task. And for information retrieval method, because we can reuse the comments and we make sure that the old comments we use definitely make sense. So it's not like when you generate from neural network, sometimes you will get totally nonsense English sentences. And for neural network method, the advantage is that you can translate any code. So you don't have to keep a reference code database. Yeah.
I think it's almost reached the points, right?
Yeah. Yes.
Yeah,
yes.
this is very excellent answers.
Yeah.
So the limitation of the first 2 is that the application scope. So as long as a code cannot match your template, your predefined template, or as long as the code which is not similar to any code in the project, then you have no idea you have no reference for your for your comment generation. However, for the neural net models, it can be generalized to any source code, but they're risky that and how accurate it is, because the template-based approach and the information retrieval-based approach, they're very focused on some specific domain. So definitely they could be more accurate, but the drawbacks is they're actually have limited scope. But numerical models, they apply everywhere, but their concern lies in their accuracy. The problem there is still a very high risky that a neural network model will generate nonsense. Yihao, you can complement my comments.
Yes, that's exactly the points that I want to say.
Okay.
So let me continue.
Good questions and good answers. Okay, please go on.
Okay. So the approach in this paper is the exemplar-based command generation method, and it is combining the traditional IR-based and template-based methods with the neural network. And you can see here is the graph for the overall system of the paper, of the method. And from the left, it is doing the data pre-processing. So it's extracting the source code from the repository, dividing into the commands and the source code. And then it has a retrieve module to retrieve the command and code pairs and compare the code with the target input code to get their similarities. And once we have a similar
Can you use annotations to mark where have you gone? So.
Oh, okay.
Mm.
How to use it?
So when you're suspend or hand your mouse on the top center areas, you're supposed to have a menu list. In the menu list, you can select annotate.
Here?
You are using Zoom, right? So you should move the mouse to the top of the screen, top center of the screen. And you're supposed to have got a menu.
I use draw, is it?
Yeah.
Can you see the?
Yeah, yeah, we can see that.
Okay. Okay. So so here, the first stage is data preprocessing. It's to extract the code and commands from the source code repository, and we divide it into commands and the source code. And then there is a retrieve module here. So in the retrieve module, it will compare the existing code with the target input code. If there is a if we find the existing code with high similarity with the input code, then we input both of them into our refine module. So here in the refine module is a neural network. It will encode the input code and the similar code input code here, similar code here, and the exemplar command by using the encoders, and then by using adapted attention mechanism, the model can generate the commands using the decoder. So this is the overall workflow for this approach.
So yeah, I think it's quite clear, but do you have any questions here?
Me?
Yeah, do you have any questions here for the audience?
No.
Maybe you can think about a question here. Okay, let me raise the question. So given Yihao's descriptions, I think he is very clear that. So definitely there's a neural network models, there's attention mechanisms. So what is the input and output for this model? Right, this is a very simple question. In this case, let me think. Xiangling, oh no, Xue Zhi, sorry. I'm going to still ask Xue Zhi. Xue Zhi.
Yeah.
So can you answer these questions? Given these neural network models, what is the input and output of this model?
The input is the code it extract from response tape.
So I'm making I can make the questions more in a more template way. There assume the input have 3 input and there's an output, right? This I1, I2, and I3, and there's an output. So can you fill in? Suppose this is exam. Can you fill in what is the input? What is the 3 input is, and what is this one output is?
In my mind, the first one is the origin code snapped, and the second one is similar code snapped, and the last one is the template, and the output is the common.
So you mentioned that I'm writing down here. So the first one is the code snippet, right? Maybe the
Yeah.
question code snippet. The second is the code snippet. It's still code snippet, right?
Mhm.
For what?
The similar code snap.
Okay, this is a similar code. And what about the third template? What about third input? I remember you mentioned this
the
template.
Template, yeah.
The template for what? So this is a comment. So that's very,
Yeah.
very, very. And what is this template about? And can you raise examples? Because the word template is very general, and they can be more specific about what this template looks like.
The code prepare from
The code. Okay, how about Xiangling? Hello, Xiangling.
I feel I quite lost in this presentation, so sorry.
Okay.
Yeah.
Okay, so Ruofan, can you answer these questions? Are you agree with
Actually,
Xue?
shouldn't the third input to be the comment
Yeah.
comment representation?
Yeah.
And
So,
the
please.
output may be a similarity.
The output is comments. So let me rephrase it. What Yihao makes here. So because this is why I keep raising the questions here, because this work is very it's integration between the comments generated between the the natural language processing, the neural network trainings, and the software engineering. So it is more like interdisciplinary work. So that's why I keep raising the questions. So Zhengfeng, are you still listening? Hello, Zhengfeng. Okay, I think Zhengfeng is missing. So whatever. So here, this is a network, and so the idea, so you can see this approach, the title of this approach is exemplar-based comment generation. So the idea is is that there's a piece of code C1, and there's another piece of code C2. And C1 have some comments here. And the idea is that based on C1 comments, and also giving that C1 is similar to C2, and then we're going to generate comments on C2, right? Yeah.
Yes.
Yeah. So the network input is very clear. The first input is the code C1. C1 is going to be here, and the second input is C2 is here, and the last input is not template. It is the comments above C1 should be here.
Comments about C1.
Yeah, the comments above C1. And
then your output is for
the
what?
The output is here. The output is the comments above C2.
It's the comment about C2.
Yeah.
So you want?
Is that correct, Yihao?
Here, what is C1 and C2?
C1 and C2 are similar code.
Yeah. So C1 is our is the existing code, right? And C2 is our target.
Yeah.
That's right.
And the output is the comment. So the idea is that given C1 and C2, and we know they're similar, and also we know the comments above C1, and we would like to, based on these three inputs, and automatically generate the comments above C2. So this is input output of the method.
So these two are actually together. The exemplar representation is for the input code, but not for the similar code.
Again.
So you have three inputs, right? The first one is the code for C1. The second one is code for C2. And the third one is a comment. And this comment is for C1.
Mm.
And your output is generated for C2.
Yes.
So your output is generated for similar code representation.
That's what I understand.
No,
Then-
no.
No.
The output is generated for the input code.
No, the problem here. So what ROFAM means is that, so the input is the question. Let's say the input code is question code, right? So let's
Yeah.
see question code here. The question code is C2. Because C2 we lack the comments for C2. So C2 is the question code or the input code. And this similar code, this similar code is a code similar to the input code or the question code that is here in the C1.
Yeah,
And the exemplar presentation is the comments for C1,
yeah, that's correct.
right? So we're going to, based on these informations, and generate comments for the input code.
Okay.
Okay. So I hope that we make everything clear now. Xiaoling, are you still losing?
I'm checking the paper now.
If you follow our discussions, I think you do not need. I think it's getting quite clear. So I may repeat again. It takes time, but I think that's my last time to repeat it. The input is getting their two pieces of source code. They're similar, C1 and C2, and C1 has the comments, but C2 does not have comments. And the neural network model is going to base on C1, C2, and the comments for C1 to automatically generate the comments of C2. Okay.
But why do you need comments for C2?
Because the goal of this research is going to automatically generate the comments for C2, giving source code.
Okay.
Okay. Okay. I think everything is clear now. Yihao, please go on.
Okay. So in the retrieve module, the retrieve module is to retrieve similar code from a retrieval corpus, given the input code and treat its comments as an exemplar generating comments. And this paper is using the BM25 as the similarity evaluation metric. You can see the formula below. Let me show. So here, this score representing the BM25 similarity function. And the IDF is calculating the inverse document frequency. The Q here is the query token, the ith query token in the
here
BQ.
you can start with DNQ. What DNQ?
Okay. D is the document, and Q is the query, and Q has it consists of n queries from 1 to n. So here Q equals to Q1, Q2.
So the Q is a set of queries, and D is a set of documents, right?
Yes.
And the goal is that giving a set of query and a set of documents, and how consistent this document is corresponds to the set of queries.
Yes, correct.
So the query is still a lexical. Is it still a lexical token?
Yes.
Lexical tokens and documents. Okay.
And the F is the term frequency, is calculating the term frequency with respect to query I and the document. And the K and B here is the free parameters to set. And here the AVGDL is the average document length. Yeah, so this is the formula to calculate the the paper used to calculate the similarity between the source code and to measure the code similarity.
So from the rationale is that if we ignore the IDF is actually a normalization functions. So the idea that the more frequent a query appears in the documents, the more likely Q and D has the largest score, right? The largest score they have, yeah.
Yes. And the whole process is has two stages. The first stage is to create the index. So it is to tokenize the source code and commands. And then after tokenizing, it will process each code and command pair into the document and store it on the disk. And the second stage is for searching. So it is to get similar code sequences arranged in descending order of similarity. And the following refined, it has two modules, retrieve module and refine module. So the refine module will choose the first ranked similar code and use the command as exemplar. So in the refine module, once we have the exemplar, a straightforward way is to treat it as a command for the input code. And here is the question. It's quite straightforward. What are the limitations for this straightforward way? So let me repeat the question. Once we have the command for the existing command for the similar code, why don't we just use it use it as a command for the input code?
By the way, Qing Zhou and Nima and Aaron, are you listening? Still following this presentation?
Yeah. Okay,
so maybe Nima, will you please, can you answer this question? Because you're supposed to using RN and transformer later, so the technique is still somehow related. That's why I ask you the question. So maybe I visualize the question a bit. So what Yihao proposing is that given the C1 what Yihao present just now is that there's a way to calculate similarity, and we have already now C1 and C2 are similar, and there's the comments of C1, and why not we straightforward copy and paste the comment to C2, right? This is the question.
Yes.
I have an example in mind. I don't know if it's relevant or not. But for example, if C1 is sorting a list called list1, and C2 sorting a list called list2, maybe we want a specific comment to C2 that will be sorting the list2.
I think that's correct.
Yeah. Yeah.
And I can raise another example. So suppose C1 is a code to find the minimum of the list, and C2 is a code to find the maximum of the list. And the code of finding minimum and the code for finding maximum is just change the greater than operation into smaller than operations. And definitely C1 and C2 are very similar in terms of the code appearance, but the comments need to tailor it to change the maximum to tailor the comment. We need to tailor the comments from the minimum to maximum to customize to the code.
Yes.
Otherwise, the meaning was completely different, or definitely it's an incorrect comment.
Yeah.
Okay.
So so the solution here is to use the exemplar as a soft template and refine it according to the semantic difference between the source code and the similar code. And this paper has proposed a novel network structure that can learn the semantic similarity between the input code and similar code and refine the exemplar to generate a comment. And here is a motivating example. So we see the left picture first. So the function here, this is a Java method to wake up at most one thread sleeping on the condition variable. And the retrieve module has identified a similar code at the lower section. And you can see at the bottom that the ground truth is written by human, and it is a command saying that it is to wake up at most one thread sleeping on this condition variable. And the exemplar, which is the command for the similar code, is to wake up all threads sleeping on this condition variable. And the third one is the AST attend group. This is a very popular neural network methods.
So this is another tool, right?
Yeah.
This is another tool generated. So wake up the threads if necessary. So this is still a network-based approach, right?
Yes, this is.
And where does it publish?
I'm not sure. I don't know.
You should know right after the presentation. Okay, please go on.
Okay. So this example is we can see that for this the input code and the similar code, they are actually quite similar because they're not only because their matching tokens are the number of matching tokens are great, but also their semantic meanings of this code snippet are quite similar. For the right picture, we can see that for the input code and the similar code, although there are some matching tokens, but their semantic meaning are quite different. So in this case, we cannot just use the exemplar, which is the command for the similar code. But so the neural network should be able to adjust based on the similarity between the input code.
So based on their metrics, they believe that these two codes are similar.
This is based on the IR search techniques.
But is that similar? Array length characters in queues. And why does the last part code be considered similar?
Because there are some matching tokens between these two code snippets.
But I assume they're completely different piece of code, right?
Yes.
And giving their two different pieces of code and the comments for the similar code, and how do we reference and why does it make sense for us to reference the comments for the similar code? You can see the ground truth of the input is enqueue a new array into the pipe. And the example is the access notification about the character events. I think this is totally it's just almost like apple and orange.
Yes.
Total different things.
Yes.
And how their approach can address the right case.
Because both the input code, the similar code, and the exemplar are the input to the neural networks. So the neural networks will be able to learn based on the similarity, based on the semantic similarity between the input code and similar code.
But there's no semantic difference. There's no semantic commonality or similarity between the input code and similar code in this case.
Yes.
And the question
So-
is how the ground truth or how the exemplar comments can contribute to the ground truth.
So I think in this case, the neural network will not rely much on the exemplar, or it will just ignore the
so
exemplar.
that
Yes.
means these neural models actually unify the so that's why you mentioned it is a hybrid approach. If the
Yes.
semantics is large enough, it will just generate the code by itself. Otherwise,
Yeah.
it will just will have a reference
Yeah.
about the similar comments.
Yeah.
Okay, so the structure of that will be a little interesting. Let's have check.
So in the refine module, it contains 3 components. There are 4 encoders, and 1 decoder, and 1 attention mechanism module between the encoders and the decoders. So the 4 encoders are the encoders for input code, for similar code, for example, and 1 additional for the AST of the input code. You can see, okay, let me draw. Here, the paper, here you can see this structure, the paper is using the LSTM to encode, as the encoder to encode the input code and similar code.
So each input code is a function, right? A functional code. I mean the length, we're talking about the length of code. So in his training data, each input code, each input code sample is a function, a Java function, or Java method, right?
Yes, Java method, yes.
So here's the risky that the LSTM will lose some relations. Might be, but not quite sure.
So after encoding these 4 input, then it will compare. Here it will compare the similarity between the input code and the similar code inside the neural network. So using this formula.
So it's almost training a separate network. So the network to compare the similarity of 2 pieces of code, or the network to generate a decoder. So they train all the, so you can see the task here. The task of calculating the similarity should be somehow independent, right? It's somehow independent to the encodings.
Yeah.
Right. So straightforward, in a straightforward way, we can somehow adopt another technique just to compare the similarity of 2 inputs and using that similarity as the input of this network. But maybe the efficiency is not so high. I'm not sure. Because network is very efficient to embedding stuff. But anyway, how we embed the code, or to how we embed the program code, program languages, it will be still kind of be a challenge.
Yeah.
Please go on.
And in the combination stages, it is combining the input of just calculated similarity score here, and all the input, all the encoded input from the 4 encoders. So here is the information. Here is the formula to combine all the inputs. It will calculate. It will combine the similarity and the hidden vectors using the previously encoded inputs. So here the
So what does H0 prime means?
H0 prime is the output for this combination.
And what does HC means? So
HC is defined.
Each H is a hidden unit in the LSTM, right?
Yes.
So it will multiply by the similarity and what does HR means?
Here is the output for the last hidden vector for each of the input here. We have HS, HX, HT, and HR. So HR is corresponding to here.
And the HR minus 1.
HR minus 1 is the last hidden vector.
Oh, the H1 minus 1 is the last vector. And the HC is the AST.
HC is defined here.
So what's the rationale? What is the rationale? Why is it designed a structure like this? So here, so there are a few questions here. So AST is actually a tree, abstract syntax tree, right?
Yeah.
So 学制 know about abstract syntax tree, right?
Yeah.
Yeah. So here the questions is that given a tree, how it can encode the tree into a sequence of ASTM. I'm not asking you. I'm asking Yihao here. Because you didn't read the papers, definitely may not be answered. But maybe you have the answers, even if you didn't read the paper.
Sorry, what is the question?
The question is AST is the tree structure, and how does the authors encode the tree structure dataset, data structure into an ASTM?
It is using the recursive neural network.
Recurrent neural network model is for sequential model, but there's a structure here. The AST is more like so let me say int a equals 1, right? This is program languages, but in terms of program syntax tree, it will more like a tree like this, right?
Yeah.
And how does this tree will be encoded here?
I mean, one way is to use the recursive neural network. It's not the RNN, it's recursive, it's RVN.
Obviously, this is not recurrent, it's recursive neural model.
Yeah.
And but what's the relation between recursive network and the ASTM? And how is this being coded? So the idea is that how it is being coded and how the syntax information is used here. So if we just look at the plain text of this code, we have no idea what it's int about, and we have no idea what A is about. But by combining the AST, we know that this is a type, int is a type, A is a variable, and equals is operator, and one is integral, is numeric literal, right? So when we have this information, we somehow, but the point is that we have multiple ways of leveraging this information. So here I didn't quite get the design structure here. I have no problem understanding the similarity calculations. And how these H0 is combination, right? H0 prime is combination between this SC is the exemplar, R is the AST, C is the exemplar. Correct me if I'm wrong.
Yes. So here it means the formula means that if the similarity score is high, then it will use more from the exemplar, and if the similarity score is low, then it will depends more on the
AST
input code. Yeah.
This is X, HX, HT. Oh, this is T here. This is X here.
Yeah.
Okay, C is a combination of these two, right?
Yeah.
And the exemplar, where the exemplar is, C is R is here. R is exemplar. All right.
Yeah.
R is exemplar. So it will be here. Okay. So Let me think about it. And the question that does the length of hx and ht the same? Oh, but it is it's the last element of hx and ht.
Yeah.
So, but based on this graph, even hx1, hx2, it will be put into combination.
No, only the last hidden vector will be put into the.
So it means but why it will draw a line between h1 to the combination? Right? Isn't it weird? So based on the formula, it seems that's only the last one. So that means the last one embedding all information of the whole sequence. Am I right?
Yeah.
You can.
This is a good question. I didn't notice this line.
Anyway, so okay. So but there's no particular design for the original. And also another question that does the length of AST, or maybe not necessary, because it only looks into the part. So here the question, if it is using every node, because here for the import code, every token will be embedded as a vectors. And this vector, if these vectors is used in the combinations, then a follow-up question is that whether these two sequences of the same length are of the same length. Right. So basically, they should be aligned with each other. If they're used together, But of course, if we just make the formula, it doesn't matter. AST can be longer or shorter. It doesn't matter. So we just need to combine the ultimate encoding or ultimate embedding vector feeding into the combination of the coder.
Yeah.
Okay, I think the structure is quite clear now. Anyone had questions for this architecture? And Yihao, you're supposed to have another question, the last question, right?
I need to prepare 3 questions.
Okay,
I have a question. So
Okay.
you mentioned about the attention mechanism. So how did the attention mechanism work here?
So the attention mechanism is designed for each encoder and the decoder, between each encoder and decoder. It doesn't show here, but later we'll explain briefly.
Okay.
Okay. So the structure still, now look at the structure, I think it's a little bit straightforward, right? So they introduce the similarities, and the similarity actually the similarity is more like attention. The similarity and this attention is not learned. It's still learned, right? The similarity is still learned.
Yeah.
Okay. So it's more like the similarity is more like attentions, and it control the attentions and to switch between the exemplar comments and the original source code.
Should I continue?
Sure.
Okay. So the training objective of the refine module is to minimize the cross entropy. So here, the n is the number of samples. The big N is the number of samples, and the y is the ground truth. The ground truth comment tokens. Yes. So during the inference, the decoder.
So y is supposed to be the embedding of the ground truth. Right. So the ground truth is actually a natural language sentence, or multiple natural language sentence. And this yi is supposed to be the embedding of source one.
Yeah, it's the embedding.
So usually when we're doing embeddings, we're supposed to have y and a y hat, right? And y is the ground truth and the y hat is the predictions. So how does these yi encoding the difference between a ground truth and a prediction?
Actually, it's the p of yij. So that means the probability of outputting this yij as the j's command, j's token of the command. So it want to the objective is to minimize the negative probability of optimizing of outputting the ice token of the ground truth commands.
So suppose here, let me say today, suppose the comments is today is a good day.
Yeah.
Is a good day. And the zero is supposed to be a difference. So here the length of J is 1, 2, 3, 4, 5 is 5, right?
Yeah.
So it is supposed to about its object functions is going to say the first token must be today, and the first token must be today, and the second function must be its, right? Suppose it is saying if I'm prediction that a good day today, a good day today. So suppose I make such a prediction, it will be completely different. It will incur a huge cost according to this cross entropy loss function.
Yes.
It seems that there's some room to improve here. Okay.
Okay, so during the inference, the decoder will generate the commands token by token from left to right, and it will also keep a beam size to do the beam search.
Sure.
To keep the best candidates.
So are you familiar with the beam search?
Yeah. So it's a technique to keep the top n best results when calculating the.
Okay, so maybe we do not spend time because it's already close to 4:30. But I suggest to other students, if you are interested, to Google Bing search. What is Bing search offline? Okay, please go on.
Okay. So here is the experiment.
Done. The method is just done. It's too simple, I think. Please go on.
Okay. So the data set is containing 5.1 million Java methods from the source repository. And here is the graph shows some information about the data set. You can see that the code length and the command length respectively. And the evaluation is, the paper uses the blue as the evaluation metric. So it is calculating the geometric mean of the n-gram matching precision scores. And here you can see the 13th equation as the formula to calculate the blue score. Maybe I will not go into the details for calculating this.
Yeah, so maybe you can skip what is blue scores, but I also encourage interested students to find what is blue here.
Okay.
That's all the traditional terminology of natural language processing.
And the paper has compared their methods with the neural network baselines. And from the table 2, we can see that the paper's method is called the R square comp. And you can see all the blue score from the composite B to the B1, B2, B3, B4 all improves by a large margin. And we can also observe that for the B4, which is calculating the similarity between 4 n-grams matching between the two tags, two sequence, and you can see that the B4 score is improved by a very large margin, indicating that the overall quality.
By the way, Xianling's question is that where the attention mechanism used, and it seems that the push has already ended. But I didn't remember there's an introduction about the attention mechanism.
Okay. Maybe I forgot to include the slides.
Maybe let it go. Let's go through the experiments first. And
Yeah.
I do have some comments and on this one.
Okay. And the table 3 also shows the exact effectiveness of the exemplar on all the neural methods. So you can see that when those neural networks models added with the exemplar, with the guidance of exemplar, then the performance also improves a lot.
So they supposed to have a version of non-exemplar and exemplar version, right? Two version.
Yeah, the left one is the non-exemplar version.
And the right one is the exemplar version. Exactly the same. Did you
But
copy
the score is not same, right?
the score on CSE?
Yeah.
Huh? But didn't we look into the name of the approach is this one, right? And
yeah, these two are the same. These two are the same, but the comparison is between the other methods. So when the other methods are added with the exemplar, they also improve on their.
And how do they add the exemplar? This exemplar. So add the exemplar functions of their approach.
They didn't mention.
Okay, please go on.
Okay. And here the graph also shows that for different code length and command lengths, the performance of the paper's approach comparing with the old SOTA approaches. So with different code length and command lengths, the paper's approach is quite stable and outperform the previous SOTA approach.
I think we draw very little conclusions and again very little insights based on this quantitative analysis. I understand so there's a way to turn up the blue. I think as the students from Peking University, they have tons of way to make the statistics look good. But I'm more interested into the examples and how the approach can outperform the rest in terms of these with some qualitative, not quantitative, qualitative analysis.
Oh, you want to see some concrete example, is it?
Yeah.
Okay. So maybe let's skip the last slides and then here are some examples. So each example is with the human written commands, and the engine is the SOTA IR-based techniques, and the AST attend group is the SOTA neural network-based approach. And you can see that in these 3 examples, the paper's approach, the commands generated by the paper's approach is most similar with the human written commands.
And there's no reason for that. They can just manually pick up the ones with the highest blues
Yeah,
just
yeah.
cherry pick a few ones and just report it. This paper, I think, telling a good story at the very beginnings, but at the end, I think for the neural network part, there is most black box, and I do have an idea. So the idea that the exemplars definitely improves upon the work, and also their approach have a lot of quantitative analysis. So I have quite a few questions here. First is that since this is a state of art, and this paper have claimed that their approach outperforms the rest baselines. So have you ever tried to run the approach? I assume that they have already published their code, right? And then as long as together along with your training set.
The code I haven't found.
You haven't found their code.
No.
So they do not mention or they haven't published their code.
I searched for it, but I couldn't find it.
Okay, maybe I contact the researchers first. If not, we officially send an email to the Peking University to ask for the code. We would like to definitely we will not write the code ourselves. We're going to reuse their code as a baseline. That's the first. That's the first issue. And the second is that for the objective function, I feel that their objective function is too brute force, and despite the results looks good, but they have no fundamental or insight for suggestions. So they just hybrid approach. And also, we're supposed to have meetings on this Tuesday, right?
Yes.
So I may drive a few of my plan of the research. So I think the exemplar work can be further improved upon it. So, but still need to think about how to further improve upon it. We can still adopt these hybrid skeletons, but look into the exemplars and the predictions in a more different way. So maybe I just feel that we do not need to, as for find a similar code, we just need to adopting some traditional code clone detection tool, and that's all. So we can just separate, first we separate the network structures. We do not embed them all. We calculate the similarity between two parts of code. And so more like we have a decision here. If they are similar, we adopt this approach. Otherwise, we adopt another approach. So this is for code clone based approach, and this is based on the traditional or network based approach. So these two versions. And for the code clones, definitely there is some part of improvement is that I'm not sure how good the network can encode it, but one of the important factors between code clone is that the clone difference. The clone difference. So here, the idea is that we would like to predicting the comment modification based on the code modification. I'm not sure what a good point. So giving two pieces of code, right? And here there's some comments here, and we can copy paste it here. So let me write something here. Suppose the code, if these two pieces of code are exactly the same, we can definitely copy and paste that. There's no problem for that, right? And the challenge is that there's some modification happens here, right? Suppose we apply some clone on difference in tools, we'll find the code modified here. So I think a more robust or a more sensible or reliable way that we locate the code elements back to the comments, and then we going to automatically to predicting the modification on the comments. The idea is still that we copy paste the code. We still just copy and paste code, but we predict the modification on comments. You get my point?
Yeah.
Yeah. So this seems a more reliable way based on the code clone part. The code clone part. So the neural network model is two black box. So I well, given there's millions of code and all the statistics, I feel a little bit hard to believe this. I feel a little bit trouble for me. There's a little bit trouble for me to purely rely on the neural model. On the other hand, I think there's an important drawbacks of their approach is that they are using exact word comparisons. We somehow need to do some embeddings. For example, today is a good day, or a good day today. So these two sentences are exactly the same. So we somehow need to compare their embeddings instead of just to compare on the exact meanings of these two sentences.
Mm.
I get my point. So would you please go back to the objective function of this work? Yeah, so here, I'm not sure I understand correctly. Is that embedding, is this why embeddings? Or the embedding is maybe using bulk embeddings, giving a long sentence, we turn it into a vector. Or it is that giving each sentence, each token or each word is encoded into a vector and compare in a position wise.
He's using word.
It's using word, right? So there's a huge, I think there's a huge problem here. So if we only focus on these semantic meanings are totally lost. So here, one of the idea, will you please give me a blank slide? Okay, the second improvement is here. So even if there's no code clone there, so the idea is that we are going to embedding the giving sentence, maybe use raw data or using BERT models, and we compare the semantic vectors here. So that will allow us to have more flexibility, allow us to provide more flexibility in these object detection functions. But of course, so compared to their approach, we are going to proposing or leveraging the semantic encodings on the objective functions. Yeah, and we do not, and also we reduce the burdens of calculating the similarity and how the similarity is going to do that. We just totally separate them together, and the independent or separate. It is always a risk. There's always a risk when we are using a single network to do two different tasks. Even for the fast RCNs, it will actually still separate the models and combine them together. So here we still using but of course, so here, how do we modify the comments? We may still using network model, but these two models should be responsible for separate tasks. So in summary, separate model for separate task. And for the first task, that's the exemplar-based task, we predict modification instead of generating the sentence from scratch. And for the second task, we are going to leverage more on BERT or semantic-based objective functions than their approach. And also, given that our architecture is different from theirs, we somehow need a way to compare those pure approach. So anyway, so we still need to have a study or investigation on the pure, if there's non-clones and how the things looks like. But also we can also narrow down the scope. We are developing a new exemplar-based approach, and we are going to propose a modification recommendation approach on the copy and on the pasted comments. So that would be a more straightforward way to do this. So if we have, I suggest that we start with this first task, because these two tasks is very similar. It's very independent. Actually, they're actually very independent tasks. So if we can finish this one good first, and we can, I'm not sure whether we can, I think maybe we can, this one can be an independent paper, research paper itself. And then we're going to just separate them. Okay, that is my comment. And based on these ideas, you may think about it, and we have a more detailed discussions, technical discussions on this Tuesday. In summary, first you're going to ask for the code, and maybe I ask the code first. And if we cannot get a code, you can send the code, send the email officially, saying that we are from National University of Singapore and asking for the code from Peking University. The second, that we're trying to separate it. And this idea that we are not going to generate the code from scratch, because especially for the exemplar-based approach, we are going to predicting the modification on the patient comments. And also, when the structure is separated, and we may leverage some existing work to generate it. But in the meantime, when we are generating this network, we are going to using BERT-based semantic encoding instead of the position-wise encoding. Okay, I think that's all from here. And is there any? Have you taken notes for this one?
Yes.
Okay, so I think that's we should call day now. And is there anyone have questions for this work? Okay. I think both Qing Zhou and Yihao did a very good presentations. I understand you have you remove some part, but the whole flow is good and allows us to have thorough discussions and propose new ideas. I think these meetings is very successful, and we have some food for decision here. Okay, if there are no one have the questions, let's call it a day. Thanks everyone.
Thank
Bye.
you.